Hi everyone, I'm Claudio. It's very good to be here. It's really, so far it's been great, so I really hope I can continue the streak of good talks. So, I'm from London. Well, I'm Italian, but I work in a company, a web consultancy in London. Now, we mostly build Ruby and JavaScript application, or at least that's 90% of what we've been doing so far. What I want to talk about is basically the first Elixir project that we built internally. It's a client applications and it's running in production. So there are a few lessons that we learned while doing this, and hopefully I can share some ideas that may be useful for you if you try to do the same thing. Now, what I introduced to you is the main problem we had. So this handsome fella here, like the man, not the dog, is Mark. Mark is one of my colleagues. He writes this Ruby gem called Dragonfly. He's been maintaining it for a few years. A lot of you have Ruby experience, so you may have come across it or used it. It's a rack engine that allows you to do asset and upload management. So what you do is you plug it in your rack application or race application, and it gives you the ability to upload files and serve them back. What makes it different from other solutions is that what you define with those uploads, so for example, image transformations, so you say you upload a big image and you want to serve a small thumbnail, it gives you back a URL that has all the instructions to do that on the fly, so at request time. So the first time you request an image with a different size, it will be resized, and then it's up to you to cache it or do what you want with it. But essentially, what it does is removes the pre-computation of the image. The classical problem is you build a website, 2 years later, new design comes in, or like a new viewport, whatever you want, a new device, and then you have to spend like a couple of days going back and recompute all possible sizes of uploads that are like 2 years old. So you solve that problem just by doing that at the last possible moment. Now, how does it do that? So this is the end part of a URL. So we have a base64 encoded payload in the middle. When you decode this, it comes back as a JSON data structure, so essentially an array of arrays, where each operation, if executed like in order, creates the image you need. This one, for example, is fetch this file from a known data store, could be an S3 bucket, could be a point in the file system, whatever you want, process it and make a thumb with these dimensions, and then encode the final result in JPEG. Now, what this means is that to generate that specific image at that size with that format, the only thing you need is this URL and some minimal configuration, which makes the format pretty portable and a good candidate to be, for example, moved out of an existing trunk of an application. You can just have a separate service that does this. Now, how did we use this? And this we get to the problem, where the actual problem is. We had a client called Contagious Communications. What they do is they sell a subscription service where you access marketing content, like essentially marketing insight and analysis. It's essentially a beefy CMS. Now, we'll be talking about real-time stuff and everything. This use case is far more traditional in the web sense. We are talking about a fairly structured CMS that has at least a dozen different image formats. And all of them are executed by Dragonfly at request time. All of them require some form of interaction with Imagemagick to create them. So things like this. You start with a conversion to a thumbnail, then, for example, you cut out a triangle, a transparent triangle, or, for example, you just resize it to a different one. It's nothing particularly complicated conceptually, but it comes with a price, in the sense that you, at least in this implementation, you shell out performance transformation. If it's a complicated one, or if it's a chain of transformations, you end up writing to disk, and then you get back the result. So what does this mean? It means that you have, this is just like an hour of activity on the version we had, the Ruby version we had, or you may have like spikes depending on different factors, like latency. You fetch a big image from S3, it just takes a while. You perform a complicated transformation. If you run, as we do on Heroku, dynos are not particularly fast at performance. So if you write to disk, that may take some time. So if you look at the left-hand side, we are talking about like huge spikes and huge differences, at least in percentage terms, between fast responses and very slow ones. And also, we had a problem of not having that many concurrent requests at a time. Now, the load for this application is not huge. We usually handle like at peak times 150, 160 requests per minute. So in terms of Elixir Erlang world, this is basically nothing. But in terms of Ruby world, it becomes a significant number, to the point that we were running an application on 3 dynos, which is like 3 small servers for anyone who is not familiar with Heroku itself. All of that with some timeouts and errors, because we are very much network dependent on S3, and for sometimes transformations don't work properly if the image is corrupt or many other reasons. Lastly, because we are writing the disk, and this is where we spent like a couple of days trying to figure it out, and we just didn't figure out why, we were leaking memory and temporary files just everywhere. So in terms of usage, memory usage will just like constantly grow until Heroku decides to reboot the dyno, which it does like pretty much once a day, and then you're safe again. So thanks to actually crashing the dyno, we could survive. Not an ideal scenario. So, for example, like a bit of more insight, just the latency. So, how could we improve this? The biggest point is that we thought about rewriting and streamlining the whole thing. Now, we are still not talking about a specific technology to do this, and I feel like I need to make this point because we are very much focused here on talking about Elixir Erlang, and coming from like a Ruby company, it's very easy to like get Ruby and basically butcher it in terms of performance. However, most of the slowness of this application came from the design of its components. So we decided, what if we had an ad hoc implementation just for this use case? And like, let's try to remove the bottlenecks. First one is, instead of fetching from S3 and doing the whole handshake every time, because images were public, let's fetch through HTTP from CloudFront in front of a bucket. Much faster anyway, because the caching layer provided by CloudFront just makes fetching faster. So we removed that, at least some of the latency. And what if we could get the data, stream it, transform it, get it back and serve it to the client without ever writing to disk? We just keep it in memory. And that way, we ideally remove 2 problems. One is the slowness of the disk, and the second is we don't create temp files, basically. So we may accidentally remove the problem of those memory leaks. In addition, if we write it from scratch, we can decide to cache at different layers. Like if you have 12 images generated by the single source image, you just fetch it once and then compute all the other ones based on a local cache. Or maybe a separate cache server, like that depends on the infrastructure. So we definitely had some other options. But we also had like very strong constraints. Now, first one is it has to run on Heroku. For those who are not familiar with Heroku as an infrastructure, you have basically workers where you deploy your application to, but that's the end of it. They're not real servers for you. You have no way to target them directly through SSH. You don't control the machines, and the file system is basically ephemeral. It can go away at any time, so you cannot use them to store data. In addition, your workers are completely independent, so they don't share memory. So you cannot store things in memory. So essentially, we had like an infrastructure, and this is because just for a very simple reason. We are an agency, we don't do 24/7 support, for example, and our client is perfectly happy with running on Heroku for so many reasons, including the fact that they don't have a sysadmin. So this is fairly peculiar and I think unusual if when we talk about Erlang and Elixir, because all of it shines a lot if you have dedicated hardware, or at least basically AWS or anyway any kind of server that you can access to freely. We also wanted to try to keep compatibility with existing tools that we use, simply because part of it is convenience, part of it is a sort of an experiment to see how far we can get to without changing too much. And finally, probably the most important one, I probably should have put that at the top, we didn't want to change any of the existing URLs. This has to be a drop-in replacement that works better, but it supports exactly the same thing. Now, Elixir fits this design. Like, the most important point is that this hasn't happened the other way around. Like, we didn't try to find a way to design the software that would fit Elixir as a platform. Rather, we started from a specific need and then decided, out of a small investigation and a bit of a leap of faith, that Elixir would be a good fit. So we could have written the same thing with Ruby, and we haven't done that. So I'd like to be able to, but I can't really prove that this is inherently faster in terms of a domain, like domain problems or transforming image, than a Ruby implementation. So this is important because, and that's the basic point, if you have to like think about one thing after leaving this talk, performance, especially when you start from a platform like Ruby, can be very easy to you just miss it completely. Like, measuring things is a bit more complicated. So you have to think about what will be the trade-off, and if it makes sense to switch language altogether, or if it makes sense to stay with Ruby at least for a bit longer. So you fast forward 6 months. So 6 months means we spent like 3 weeks on the first part of writing this project, then a few half days and days over the course of 6 months to get it to production. And now it's on production and it's working. So that's, I think, a good result. I would say, like, there was no guarantee for that. It's working really good. And what I'd like to go a bit more into detail now is what are the things about Elixir, about the Erlang VM, that made it a good fit for this. Now, it's really good that I'm talking this afternoon, because some of the people before me have already highlighted some of the features of the Erlang VM. So I won't repeat what they said, but as a general rule, if you keep in mind, especially what has been said by Sasha this morning about basically the runtime and supervisors and things like that, this should be helpful to follow along. Now, let's start by one specific part, which is how do I get that data structure and execute essentially and transform whatever in a way that it makes sense and generates the result. Now, if you think about, like, how many people actually wrote Elixir code and got the idea of pattern matching and recursion, or do we need to like go into more detail to that? Oh, is that fine? Okay, good. So this is a list of lists, basically. So once you generate, once you start analyzing it, you can just like basically process it one by one and recurse and get to the end of it. And the good thing is that with pattern matching, expressing this becomes very easy. So if you find an F, you just fetch. If you find a P, you know that it's a processing operation. And the second argument, thumb, is just a bit more sugar around the convert operation, which is a low-level instruction, basically a command line instruction that you give to Imagemagick. So all of this can be configured originally in Dragonfly, so this adapter needs to support them. Now, what you can do, and this is just one of the possible ways to solve this, is you match on the thumb, and then decide, what do I do with this? This is just a convert in disguise. So what I'm going to do is, I'm going to make it a convert. I'm going to change those dimensions into a format that is compatible for Imagemagick and just pass it with a default image format and put it back where I found it. So in the same list that I still have to process, so at the top of the tail. So that way, this thumb will be processed as a normal convert operation. Now, you could have done it differently. You could have implemented thumb as a form of this. So decide to fill the struct with all the steps of the transformation straight away from this. But a nice way, at least the way I see it about this solution, is that you don't have ambiguity. Like a conversion is always a single entry point. Your steps struct always gets filled from a single point in your code. Everything else, if a thumb is a form of conversion, you can express that clearly in the method. The intent, I think, is pretty clear. You pass from a thumb to a convert. So your code is instantly clear if you read it, and it shows you exactly what the actual thing is, which is also a good thing when you get to the final result of this. Now, this is more generic thing about functional programming itself, but the way the logic ends up being modeled is that there's a clear separation between the data and the structs you carry across between the different stages of your program and the logic that executes them. Because this is what in terms of application, this application, that's what it needs to know about a job to execute it. There's no behavior attached to this data structure. There are clear keys that indicate what this job is. You, as a human, can inspect it and understand exactly what it does. If you want to have a debug endpoint to see this information, you can mount it pretty easily. But essentially, even in terms of testing and doing like proper integration testing of this application, you can just say, given this data structure that represents a job, do I get the right image back? And this is incredibly useful when you want a unit test that everything is wired up correctly, because it just makes it easy to reason about it. Compared to the Ruby code, there's much less ceremony in the execution. It's just data that flows through a function and gives you back an image. And because that's simple enough, then you can think about your pipeline of work and isolate it and put it into a process, into a worker. Like every transformation is taken care of by a separate worker. There's complete separation between the application in terms of web stack that gets the request endpoint. Then as soon as you get the base64 payload, you pass it to a worker, and at that point, the worker is going to take care of it completely in parallel. And inside the worker will dispatch will send different messages to different processes to compose this data. So it will talk to a HTTP fetcher process that gets the data. Then it will talk to another process that passes it to Imagemagick and gets the data back. And then all of this will be sent back to the client and back to the actual web layer and the socket. So instead of having top-down logic, which was the Ruby implementation, you have separate discrete processes, separate entities in your actors in your application that all run at the same time. And what you can do, you can reason about them in a simpler way, because when you talk about a transformation is just an isolated worker, so you can handle it separately. You can treat it as a single thing. You can test it independently. Your web layer doesn't need to be concerned about that. It's not just a matter of separation or concern, but even in terms of resources, your HTTP layer that is waiting for requests to come in doesn't have, it's never going to be blocked by what happens at a transformation level, because they're running completely separate pipelines. And how does this work, or how does this look from a point of view? So this is just a screenshot, which I hope it's barely readable, at least from the bottom. But it's I can show it to you later on. Like live in the machine if you're interested into. But this morning, like Sasha talked about supervisors, and that idea has come up in a few different talks today. Now, if you haven't tried before, the LMVM and Elixir, they ship with a graphical environment, which is the observer. The observer allows you to run and target either your machine or like another node and see your application as it runs, which means that all of those processes can be represented into a tree. And this tree is inspectable at runtime. So you run your application, you let it run, and see what happens. Which also means that if you want to reason about code, you can actually look at it and see that things are running the way you expect them. Now, this list on the left, each line is one of the discrete components that runs inside the application. Basically, all of the applications that compose yours, most of them are dependencies, like an HTTP layer, like the process that manages the connection with Imagemagick, like all of this. Then there's your domain logic, so this application. And the way you can implement this is one possible way is that you have different supervisors for each part of your application. And each one of them, for example, the bottom one is the one that supervises the jobs as they are executed. And it supervises a pool. And this is a pool with 10 workers. Each one of them is ready to be checked out, execute a transformation, and put back in the pool. What does this mean? What this means is that anything that happens during transformation, if it happens to fail or break, it will go as far as the supervisor, and the supervisor will block the failure there and will catch the failure and decide what to do next. What could go wrong? And this is where there was again, it was mentioned this morning about what does it mean like failing fast or letting it crash. In my specific case, it meant that if you have an archive with like 20,000 images and 5 or 10 of them happen to be corrupted because maybe they've uploaded wrong ones. Maybe the upload, if you upload a 5 megabyte image, every once in a while it just goes wrong. So what do you do at that point? You fetch the image, you try to transform it, Imagemagick fails. Now, in our case, like it didn't make sense, or in general, like to predict that. It's basically unpredictable. We didn't know upfront what were the images that could cause that failure because some of them date back to an archive that had been imported ages ago. So when a transformation fails because of that, we literally have no code at the worker level that cares about that. The worker just crashes. The crash gets caught by the supervisor. We get a stack trace about that in the logs. And then we're going to see what image caused that and basically tell the people who manage content to like swap that image for something that works. But the good thing about it is that the logic in the application doesn't have any mention of that problem. That's a problem that is just very difficult to predict because of its nature, and we just have like the golden path implemented. So it works nice 99 point whatever % of the times, and we just write code for that, which means that we can get to a good representation of how the domain should work without being too defensive about what could go wrong. And this is good because it makes it easy to reason about it. And the same thing goes for all the other parts of the infrastructure. It's like that for the caching layer, for example, but it can be the same for the HTTP fetching layer because HTTP, like, yeah, we are fetching from CloudFront, so technically it should always be up. But how do you know that's going to happen? We do just a bit of error handling, but barely enough so that we get good error report when things go wrong. And the result of this is that we have a much better performance graph now. We are not spiking, at least not often, to more than a minute, at least for the average. The total size of the application is 1,000 lines of code, including tests, which is very manageable for something that has been written from scratch and then solves this problem. And this is where we get real benefits from the, as well from the Erlang VM. On a single dyno, we get twice as much capacity as 3 dynos before in the Ruby implementation. And this is because we just set it up to handle 100 concurrent connections at most, which we haven't even reached yet. So right now, we are running the application with a configuration that is far lower than what it could handle on very cheap hardware, simply because we don't need to push it more than that. The memory usage is stable. It's basically starts pretty slow, 30 megabytes, then it gets to 160 at full capacity, but it stays there rock solid. So it's very good because it makes it easy to predict how much you need to add if you want to scale more. One of the reasons why we're using workers, for example, is that we kind of have an idea of how many processes and how much we can add if we need to add more capacity. So it's just a better design, and that's enabled by the fact that the platform allows you to think about things in that way. But obviously, you get to pain points because it's very difficult for a project test to be completely painless. Part of these pain points are related to ourselves as a company, the experience, the fact that it's the first Erlang/Elixir project. Part of it is the nature of the problem and the domain and the constraints. So, is there anyone from Heroku at this conference? Okay. No, I was I asked because I'm actually wondering if there's a way to improve this situation. Like I don't want to say anything. So personally, I don't have a problem with Heroku in itself because it solves a lot of my problems, which is I really like my weekends to be just weekends and sleep at night. So that's a good thing. So to do that, someone else has to manage the infrastructure. So Heroku does that. But it comes with a price. We said before that you don't have SSH access. By extension, you cannot use any of the existing, as far as I could figure out, and please prove me wrong if you know anything different, but you cannot use any of the existing tools provided by the Erlang VM to profile a running application. You cannot attach a console to it, for example, and you cannot run remote code to it. So, for example, I cannot run an observer on a different machine to see what's happening on my running cluster because I simply cannot target them by IP address or anything like that. They are behind the proxy. They don't even expose a TCP connection of any sort unless you ask it. So it's very difficult for that to do. And resources are constrained. We are processing images with Imagemagick, so we could just you crank it up the CPU and at least the transformation layer could be faster. And if we could have a dedicated infrastructure, you wouldn't even cache on memcached externally. You just keep it in memory on the machine. And finally, we have a custom build pack, which is a way to deploy on Heroku. There's no standard Erlang release. Effectively, some of the toolchain had to be a bit custom. And like someone else before me did most of the job, I just had to make a few changes to existing build packs. But that means that you lose the ability to tap into certain cases, to tap into existing Erlang knowledge, which is a bit of a shame because some of the problems have been sorted out for years. At the same time, the libraries and developer toolchain, in this specific case, sometimes it was a bit of a nightmare in the sense that when it comes to, especially like what Francesco was talking about before, like profiling your application, have alarms, all of that kind of nice things that you really want to have on a running application, that was a bit frustrating because if you run Ruby, you usually use something like New Relic to profile it. But the New Relic client that you can use with Erlang is a reverse engineer of a Python version that has to be plugged in manually. Like it's a bit of a hack. So we try to use it, but it kind of works, but not that much. So there's a bit of a problem, and this goes into the familiarity of the tools that if you have other 15 developers, you want to try to keep it a bit familiar, at least for them, because otherwise the transition becomes too painful. And we are using logs to catch exceptions, like send me an email if you see this in the logs, which is not ideal. It's okay, but sometimes if it's an unpredictable error, if you haven't known it, if you haven't seen it before, you may forget to add a clause for that. Finally, and this is more about the Elixir ecosystem, some of the, like for example, like Memcache, there's one library, there's also another Erlang library to use it, but none of the existing libraries support, for example, Memcache authentication. So we had to add that on top of it. And some of them are not particularly robust. If Memcache goes down, you kind of have to handle all of that on your own, which means that we wrote code to handle these problems, which could be baked into existing libraries. So there's a lot of opportunities in this. I think that's the thing that I'd like to take away from this slide, is that there's opportunity to improve all of this, whether it's using or training about different tools, and they're the solutions that Francesco mentioned are a good, definitely a good way to go, but also something that could be more specific to smaller use cases or integrating with different platforms like Heroku. So there's definitely a lot of opportunity from that point of view. The learning curve. Working with, and when I started this project, I had a good year of free time development with Elixir, pet projects, whatever you wanna call them. Basically, no production code, which means that I thought I knew what I was doing, but that's not always true. The problem is, if you have a company that basically it's a company that lives with object-oriented languages, the transition to a language that is functional, even if not completely, it's difficult because the ideas are slow to sink in. It may be just peculiar from where I work, but I think it's a general thing about, especially if you come from the Ruby community, which tends to be opinionated and to some extent really like their object, with a different flavor than Java, but they really like their objects. It's difficult to make the transition. Pattern match is an incredibly powerful tool, but if you mix it with recursion, it's difficult for people to embrace it quickly and use it to do control flow. And this is also because Elixir provides other ways to do that kind of thing. Why would you use recursion if you can map over a collection, for example? It's difficult to decide when one is a good pattern or one isn't. And it's very easy to write code in Elixir that deceptively looks like Ruby, despite the fact the semantics are completely different. So sometimes there have been moments where you just have to go through things step by step, and progress may be really slow. And finally, you get to OTP, which is powerful, but again, difficult to grasp as an idea. If you come from Ruby and JavaScript, you have no idea what basically truly concurrent actors are. Maybe you try to use different Ruby libraries to have that kind of feel, but the reality is it's a completely different way to think about it. And OTP and Gen servers are, you just have to build that knowledge. And there's a surprising difference between a small OTP and Gen server example that you write and you think you got it, and running the whole thing into production. Things like, how do I track a memory leak, for example? Like, this application had to deal with binaries, big binaries, which if you use Erlang, you may end up seeing, oh, how are they handled? Why are they staying in memory? How come they are not garbage collected? Why is my memory usage spiking so much? Luckily, there's literature about that, but it just opens a whole set of problems that you haven't seen before. So, and this may be obvious and applied to any other language, but the point is, it does come with a price, but it's a good price, I think, to pay. And I think, ideally, what you want to do is isolate a good use case. If you're thinking about, and if you had the same problem that I did, which is like, how do I make this happen? How do I build the first thing in the company that is not written in Ruby? Finding a good use case is not that difficult, but the important thing is that I think you start from the requirements more than the tool. I would have wanted to do this like ages before on so many other projects, but I never found a really, really good fit. And finally, this chance happens. So the domain problem is the most important thing. And then if it's a good fit for Elixir, like go for it, even if it looks risky. Hopefully you will be able to convince your boss or client or decision maker or anyone you need to. But I think, and we have an opportunity with a toolchain to make it more approachable for beginners. Things like quick check. There was a really good example before. It just makes it very approachable. And then property-based testing is a fairly new idea that you don't, at least for a Ruby programmer. Things like that, lowering the barrier of entry is useful because that way you can get more people on board when it makes sense. So if you're curious about the code, and I really encourage you to open it and, I don't know, open issues, comment on the code. Being the first project, you will find, especially if you know what you're doing, you will find things to tell me about, hopefully positive criticism. Please do, because it's important that, at least for me, to have a better understanding of how things can be improved. But yeah, so that's it. Thank you for listening. If you have any questions, I'll be happy to answer. There's one.
So I'm interested what you think about the pain points given you don't run your code on Heroku but on a proprietary infrastructure. Are any of those circumvented by that, or do you think they will be the same? So obviously New Relic thing is exactly the same, right? But there was some that maybe would be solved by it.
Yeah, I think so. Like, there's even just being able to run the observer against your running instance, for example, it would have been made, for example, tracking down that binary memory leak much easier. There are good tools. There's a good book by, I forgot his name, basically one of the Heroku developers, ironically, that runs Erlang in production. It's called a book called Erlang in Anger. It's got very good, like, basically techniques that you can use to debug production and all these types of problems. And all of them assume that at least you can open an Erlang console to your running cluster. Just doing that would have been great. You could have seen like, oh, this is the process that is holding a reference to that memory. So that would have been, I would say, the biggest difference. In terms of monitoring general usage and things like that, you can end up like using Librato on top, and then your log files, at least like the general profiling of the dyno as a machine gives you enough information to have a roughly good idea. But it's when things get like the nitty-gritty details of why, for example, you have a bottleneck, that's, at least for me, that was very difficult to debug. So I would say that dedicated infrastructure would have probably made it easier in that respect, with the price that you have to manage it on your own.
Yeah, there are like there could be also tools like to do. We can see like some tools popping up to like push stuff
more for running your infrastructure. But you still like, it's there, but you still need to choose the instrumentation points, right?
Yeah.
And so it's not like, for example, if you're using Neuralink with Rails, you just install the agent and it goes and knows where to look and get instrumentation points. So right now we're at the moment where we are starting to have tools that do integration, but you need to go and add those points where you want to instrument yourself.
Yeah, that's true. But basically you need to decorate your functions to tell them like, oh, this is the things that I want to measure. And it becomes, it's good because you have in like good like fine level detail, but it's also like more work compared to when you have to explain that to, for example, like a Ruby developer who sometimes is used to like drop in a gem and then boom, profiling just works. You don't have to worry about anything else. So that becomes just a matter of understanding, and there's work to do and there's a cost associated to it. But it's a good thing to do, and it's definitely needed. Yeah. Okay. Oh, sorry, Jim, I pointed to this gentleman.
So Imagemagick sounds like something that can eat up a lot of resources. So what means do you have to control the amount of work that is sent to Imagemagick, since that seem to be able to make the whole system pretty?
Well, theoretically, yes, you could do that. Like you can basically like run out of memory if you perform like a particularly complicated transformation. In practice, it hasn't happened, in the sense that transformations are known up front. There's a limit on the size of the files now that can be uploaded, and the dyno runs on 512 megabytes, which means that it can spike to like 200-300 for transformation, but I haven't seen anything bigger than that. You would definitely have to do like a better job around that. Like in an ideal world, I'd like not to shell out and do that. There are other approaches that you could think about, like, but most of them are much more complicated than this. Like you could use like lib Imagemagick and like embed it into your, like you go into a territory where basically you would embed like C code in your runtime, which comes with a whole set of other problems and risks that at the time they seemed far greater than a sporadic possible memory spike that we didn't know anything about.
Anyone else?
So as far as I know, you're basically a Ruby shop right now, right? You don't do
Mostly, yeah.
So what's the reaction of other developers, like seeing you coding in Elixir? Is it like everybody says, oh god, I got to join this guy and coding that stuff, or do they rather speak?
People are interested when they sit beside you. The tricky thing is always get them to sit beside you, because everyone is on a project. Like there are so many, like it's difficult to get traction internally. I think that's a general problem when you're a highly specialized company, because the comfort of what you know is a very powerful force, even when people are extremely curious about the technology. They asked, all of them, they asked a lot of questions. They were interested. They were like, there was a lot of interest, but there's always a gap when it comes to actually writing production code, simply because it's risky, and like people sometimes have also different priorities. Like they show up at work and they do their job and they go back to their family. They are happy about it like that. It's just like it really becomes a people problem more than anything else. Like technology is basically irrelevant at that point. You could have done this in Go, for example, and it would have had like exactly the same problem from that point of view.
All right.
Thank you.
For the questions, and thank you.